Okay, guys, welcome back. Let's see, quick announcements just to organize this. Today, my goal is to review activity diagrams and state machine diagrams. Those are the last topics before your midterm. Those are the two last topics included in the midterm exam. Now, my plan, the one that I shared with you before, is to have the midterm the first week returning the spring break. So the goal could be we have a lecture today, spring break, and then when we come back, we have a review, and then the exam. We talk about it. Now, something that could happen, and I want to mention this right now, is if by any chance we do not finish today, and I am thinking that could be the case, it could happen that we return from a spring break. Monday, I finish whatever thing we didn't cover today. Wednesday, I do the review, and therefore your midterm could be on a Monday. I think could make sense, right? Good? Okay, so let's see. For today, we have been working with functional requirements. Functional requirements, you know what they are. You know how to identify them from a talk or a written document. You know how to put them in a use case diagram that basically represent this big picture of what the system is going to be. You know how to connect them with three particular relationships that we review: inheritance, include, extend. So you know how to do the big picture. Now, next step, we need to talk about the details. Okay, for the details, there are going to be two steps. When you have the requirements, and therefore you have these ovals, for each oval in your diagram, there are going to be two things. There are going to be things that you will need to specify using text. There are going to be extra information that we need per requirement, that there is no other way but with a note, a document to specify. I am going to mention what, but there are going to be details. Details, all the things that we review as activities, all the things that we review as conditions, states, values. Those things are going to be in more diagrams. So again, for every single requirement, for every single oval, we're going to have extra things for each of these: text, I am going to tell you what, and diagrams. So just imagine that you have this paragraph of text and these diagrams inside of each oval here. Each oval is just a point in which inside you're going to find a small document and more diagrams that explain that particular section. Think about click in one of the chapters of a book, and you go to that chapter, and in that chapter you have information. Okay, let's start with the text. For the details, this is called a use case template. Remember, use case diagram. Use case diagram, use case template. Now, common mistake. Usually, we think that because we have one use case diagram with a lot of ovals, we need one use case template for the diagram. That is not true. You have one use case diagram with the ovals, and you need one use case template, one of these, per oval. Each oval needs one of these tables. Each oval in the use case diagram, each requirement is going to have this information.
Are we doing this for the exam?
Yes. Remember, these topics that we covered today are included in your exam.
Are we going to have a template like that, or do we have to write our own template?
You are going to have it, don't worry. You are going to have this, and I am going to ask you to complete this part in the exam. One question.
What about the assignments? Are we supposed to do the assignment?
You are going to do something like this in the assignment, in the future assignment, not in the past one. So, because it's the first time that we are talking about this. So the assignments that are coming are going to include this thing. But so you're going to have one question about this in the midterm. So again, in the diagram, each of the ovals, one of these tables, clear? Each oval. Now, what do we need to specify per oval? The most important part are going to be these ones, but I am going to talk first about the easy ones. The easy ones. In the use case template, what you do is the following. Number one, recommended. For every single requirement that you have, for every single oval that you have, you are going to put a number, an ID that usually is numeric to that requirement. Which number? Select your numbers. For the Pac-Man video game, 1, Pac-Man move, 2, Pac-Man chose, 3, the ghost move. I don't know, you select your numbers. The only thing is, it is important, it is common practice to put a number to every single oval. So later you can talk about the number instead of put the full name every time. Some people use only numbers. Other people use a combination of letters and numbers, depending of how big is your system, depending of what you do with your team. It's an ID, right? So you have a particular ID as a student, and you can notice some similarities and some rules that are followed, but it's not just 1, 2, 3, 4, 5. You specify the format for your IDs is an ID. A number is just good enough. Second, together with the number at the top, in this table, you are going to put exactly the same name that you put in the oval. So to connect the oval with the table. Easy, right? If you are using this tool, ASTA, that I recommend you to do, something that you could notice is if you make click in your oval and you select use case template, this table is going to be automatically generated, and you're going to have automatically a number that is going to be consecutive and automatic the title there. That is the same title that you have in the oval. Nothing new. Okay. Next. Second row. Something that you can do here in this template is give me more information about the requirement. Because remember, what you did for the oval was to select a name. And that name have a verb, right? Pac-Man move, the ghost move, the Pac-Man chose, the ghost chose. You select a short name because the name should be able to fit in the oval. And also the idea is that it's easy to read for the other people. But here in the second row, you have the opportunity to tell me more. Do not limit yourself to this one verb and a short sentence. Tell me what could be an abstract for the requirement. Sometimes it's important. Sometimes you need to explain more. Sometimes it is not the case. And maybe you only need to add 1 or 2 more lines. There is no rule about how big this description or goal should be. It is your opportunity to communicate extra information to the team. Make sense? Now, be careful. That one, the description, is your opportunity to provide more information, but still not the detail. For instance, the ghost is going to move. The details of the ghost moving, like there are 4 different ways for the ghost to move and how those details are going to be, those details are going to be down here. And I am going to talk about this. So the description above is more than just the title, but it is not the place for all the data that the developer is going to need. This kind of abstract in a paper in which you have the title, these 2 or 3 paragraphs to explain things, but still is not the full paper, not the full document. Makes sense? Okay, yes.
20 points is this question.
20 maybe? I am not sure, depending on your exam, but something about 20 points.
So if Pac-Man moves is the requirement, what would be a good description for that? Just Pac-Man moves around the board or the grid?
In that description, I would maybe include the Pac-Man is going to be controlled using the keyboard, for instance. And maybe I am going to mention that the keyboard specifically left, right, up, down. That is a good point to put that, because that is not kind of a deep, complex description, but it's a good moment to put that particular information. For the ghost, that could be the good place to put that there are 4 different ways for the ghost to move, but still you do not need to explain them. It's a little bit more information depending of what is your project, what you are doing, but still not the place for the full details. Good? Okay. So next, important, preconditions. And this is an important concept for you to remember. Requirements have what we call preconditions. Something that should be there in order for this requirement, this functionality to be executed. Remember that several times you told me like, okay, checkout on Amazon. Checkout should be connected with authentication because authentication should happen first before I do the checkout. However, something that I tell you is, no, wait, in the diagram, we never show that. In the diagram, you do not connect authentication with checkout together because that is not what you want to represent with the diagram. Here is your opportunity to put prerequisite authentication to every single functionality that needs the user to have been authenticated before. This prerequisite is not a connection in the diagram, but it's something that you put here. Is the information for the developer that is going to create this functionality to be aware that he or she is going to need something else to happen, that is going to validate something else that happened before. Now, that means that this developer needs to talk with this developer. The answer is no, because usually these prerequisites mean that something happened here, and what this developer do is to establish a value in a global variable, a state in the system, whatever, and the only thing that this developer needs to do is to check that state or check that value, whatever it is, in order to continue. But remember, that is for the developers. Here, for the stakeholders, the only thing that we specify is what is the prerequisite here. 2 options for the prerequisites. Number 1, another requirement can be a prerequisite for this. You can select here, or you can mention here, another requirement like authentication and mention, hey, that should happen successfully before this to run. If that didn't happen successfully, then this one is not going to run. This is just going to go out to redirect to whatever. But it is not limited to that. You can specify as a prerequisite something that the user needs to do, some data that should be there, some value for some state that we're going to review later, whatever you need to happen before. Whatever you need to happen before. Run the system is not a prerequisite. It's something that obviously happened before. So you do not need to put as a prerequisite for the Pac-Man move, the user run the Pac-Man. We assume that the Pac-Man is running, because if not, what is the goal of this? So anything that you need that is not obvious, right? Clear? You do not need to put there like the Pac-Man is inside of the maze, because like there is any way that the Pac-Man is outside of the maze. And assuming that it's not, then do not put extra things. Do not put things that are obvious. Do not put garbage. Clear?
So
you do not need to, very good question. You do not need to put that because it's already in the diagram. However, you can do it. It is possible to do it. It is not an error. It is not mandatory. The assumption is that the reader check the diagram first and the details later. So the assumption is that the reader know the diagram, and therefore they include, extend, inheritance, and then go for the details. So usually we put here things that are not in the diagram, but just like when you write a paper, you can repeat things to be sure that the reader is aware of the situation. So both options, good. No, because remember, the example here is this authentication and checkout. We never connect, or one thing that I recommend to you is you do not connect authentication and checkout for Amazon, for instance, because cannot be inheritance, do not make sense, cannot be include because you do not authenticate when you do the checkout, you do that before. It's not going to be extend because it is not optional. So it's just authentication and checkout, both are services that the user can ask, but these are not connected in the diagram. However, the prerequisite is the place in which you can put a checkout, a prerequisite. Somehow the user should be authenticated. Again, talking about Amazon. Somehow this happened before. What is going to be the result of the output of the authentication? Basically, a state or a value in a variable in some kind of session or whatever that is going to be there true. And when you do checkout, the only thing that you're going to check is that true, or maybe a session object is not null, kind of true. That's it. So this is a very common example, a very good example of when you use prerequisite, but there is no connection in the diagram. Good.
A includes B. So it means that A and B both are supposed to happen. Do we also need to specify like A is going to happen before B?
No.
Then we are just saying.
If it's in the diagram, you do not need, it is not mandatory to specify again.
In that case, if there's an include that is supposed to happen before the actual one,
the include always happen before, because this, if this is the big one, this is the small one, automatically, we're talking that this is going to happen here before this finish. You do not need to put that as a prerequisite. You do not need to repeat that.
If you say A includes B, B is supposed to happen before A, always.
Always.
If like we want a condition where one of our requirements is completed and then we want to run the requirement, in that case, like we want A to be completed before B, but both should be happening.
Do not use the include, because using the relationship include means that this one, the small one, happen first. So if you want to control the order, include is not your option. If you want to control the order, then they are separated and the precondition establish the order. So just be careful to do not put the include, because the include is forget about the order, is not what you want. Here you are telling me the small one go first because it's one part.
So in the Space Invader game, if we have two stages of the game, right? When the game loads, we have the options to start the game, and then when the game starts, we see the playfield and this thing. So, for example, if there's a requirement saying move the cannon, for that precondition, can we mention that the playfield has loaded?
It can be, yes. Again, things that are obvious, like the game is running and everything is on the screen, you can ignore that. You do not need to repeat that. But if you need a particular state to happen, a particular situation to be there, a particular value in a variable, a particular object to be different to null, obviously you are not going to put that here, like this object is different to null, because we haven't created a design for the objects and the classes. But something like that, that condition of the object be different from null, is going to start, because here we're going to put some kind of condition, something that should be there or should happen or should be a value.
It's not always necessary to have a precondition.
Very good point. None of the elements there is mandatory. Obviously, the title is going to be there and the number is going to be there. The description is up to you to improve more than the title. The precondition, that space could be empty. For instance, if you think about a precondition for show the Pac-Man, probably there is no precondition. But that one is not a requirement, so that is nothing. And as I mentioned before, running the game or assuming that the game is running or the system is running, you do not need to mention that, it's obvious.
Just a follow-up. Did you just say that for something to be a precondition, that should be a requirement?
Could be a requirement, so you can mention the requirement, and that means that that requirement should happen before. Could be, or could be something else, but it uses a condition, an state, an activity. Because you are going to put something there, it could be anything, activity, state, condition, or could be as big as another requirement to happen in full. So you can think about this like can be an instruction or can be a full other method that should be executed. Both can be. Obviously, if it's another requirement, you do not want to repeat everything from that requirement. You just put the name and it's like, okay, those things should happen. Good?
You're telling us precondition in one use case
Uh-huh.
can be an actual requirement in another use case.
Yes, could be, that could be a precondition. Make sense? So all those times in which you ask like, where I can specify that this should happen before, this is the place. Specify something happening before. Good? And it could be more than one. You can think about, okay, I am going to do a payment, a requirement for, again, a web thing doing shopping. I am going to pay. And if you're going to pay, the preconditions could be you are authenticated. You have something in your card, something that you're going to buy. Moreover, you have some kind of payment method in your profile, or you already put a payment method that was accepted. I don't know. Depending on your system, anything that you need to happen before, that is the place. If you put that space empty, you are telling me, I do not need anything to happen before. For instance, authentication. You are not going to have preconditions for authentication. Well, usually, because you do not need anything to happen before. Please, precondition for authentication. The user write the email, the user write the password. Those are not preconditions, because those are going to be steps to follow. When we talk about preconditions, it's something that should happen before this requirement, the step here, to happen. Good? Okay, so preconditions. Two things. Yes.
If you mention a precondition, does it necessarily need to be a use case?
Another requirement?
Yeah.
Could be, yes, is what I mentioned, like another requirement or another use case, or use a condition or a statement or a state. Anything from something like is a complete requirement, big, to something very small, this is your place.
If I mention something which is not part of the use case diagram at all in the precondition,
A value for a state, for instance. You do not have another requirement for the value of a state, but here is the state should be, the Pac-Man should be in a hunter mode. So that is not another requirement, but it's a value for something. The Pac-Man should be hunting, which means that the Pac-Man before eat the power pill, for instance, if that could be the case. Make sense? Okay, moving forward. Conditions for success and conditions for failure. Those two can also be empty, but those two are important to connect this requirement to others. The question here is, what is going to be the scenario in the system if this requirement works, everything fine? What could be the scenario in the system if this requirement fails? And let's start with authentication. Okay, what could be the scenario in authentication? If authentication go fine, what are you going to have? In the reality, you know, it's like you're going to have a session object that have authentication true or everything true, or the user is logged, or the information of the user, whatever. That is the developer's perspective. Here, the condition of success is somehow you are in a state, or somehow you are in a position in which other requirements could happen. User can do the other requirements. User can work with the system. Users are logged in the system and can start working. I don't know. You're going to put here the idea in one way that your stakeholders are going to understand that, okay, after this happened, now I have access to other things. Or now I cannot do other things. Or now, whatever. What is the condition? What is the situation? What do you achieve of completing this requirement, all the steps, that is going to impact the system later? That is going to impact other requirements. You can use both. Sometimes you need like success and failure. Sometimes only one of them. for the authentication, a condition of failure or something that you want to mention there as a failure is if the user tried 3 times and didn't achieve to authenticate, the system is going to keep this user out. If that is the case for your system. If the worst case scenario for failure 3 times, you are out. It doesn't matter that next you do something correctly. You are not going to be able to enter.
Let's say this is the template for payment. Then, as you said, so would the success and those relate to the authentication?
Yeah, for instance, thinking about payment, right? The success of the payment is now the user can continue with the checkout. Or the success for payment is, okay, now the items are going to be sent to the user. Something that could happen. Failure. If the payment fails, something that you want to put there is, at this point, this requirement, checkout, got canceled. So what is going to happen if this works or not? The condition or the result could be that something that you are doing get canceled, something that you are doing is completed, something that you are doing is going to move to another part, is what is going to happen. And again, you need maybe both or only one, depending of what you are specifying.
Is it, this might be similar to his, but is it implied that if the condition fails, failure is handled in the precondition?
Yes. If the precondition failed, like you are doing checkout, and the precondition was the user was authenticated, and that is not the case, and therefore you cannot execute the checkout, the condition for failure or the state for failure, you can stay there, no product sent to the user, or I don't know, whatever.
Those end conditions only pertain to the requirement that's required by this.
Yes, only for this one. Think about this. If the requirement is a method, the precondition is an if condition that is the first line of the method. So that one is going to tell you if everything else is going to happen or not. And you can think about these results as the return value that you return when everything goes well, and a return value that maybe you return when something fails. Like the try catch, the return inside of the try, everything go well, and the return value inside of a catch, that is basically the return for error. Obviously, in programming, you can return null, but here you need to explain to me what is this null, right? There is no session open. There is no possibility for the user to continue using other functionalities. I don't know. You are talking with the stakeholders. Do not explain things with source code. However, I am giving you analogies with source code so you can map these ideas. But for the document, explain plain English to the people the best way that you can. There is no particular rule for that. It's your communication skill. Good? Again, they are optional. Precondition, success, error. It is not mandatory to put something there. It is your decision. Which one are you going to use? And obviously, it's about if you need them. Moving forward, the actors. This is very simple. Which actors are connected with this case? If you are using the tool, if I remember correctly, the new version, at least the professional one, put the actors for you because the actors are the ones that are connected with the oval. I am not sure if the student version that you have is going to do that, but worst case scenario, you need to put the actors manually. And literally, we're talking about the actors that are directly connected with this oval. You do not need to search for connections crazy. It's the actor that is directly connected with that oval. You can have primary actors only, or primary and secondary, or maybe only secondary, or nothing. If there is no, like, if you have here an inheritance or an include or an extend, these guys do not have actors connected. You can have that row empty. These guys have one actor connected. This in the template is going to have there the name of this actor. Done.
That actor also the inherited one.
You do not need to go in that direction. Again, you could do it. because it is true. It's inheritance. That actor is connected with the one below. You do not need to do that because, again, the assumption is the reader read the diagram, and therefore the reader know that that actor is connected with the father. The father is going to have the actor there, but the childs are going to be empty. However, I know that they are childs, and I need to check these actors here empty, but also the parent. You do not need to repeat them. You trust in the reader. Good. That is what the tool is going to do automatically. Again, if that is not the case, the only thing that you need to put there is the name of the actor, comma, another actor, comma, another actor, or empty, done. Clear? That one is kind of just a space for you to review and be sure that the actors that are connected are the ones that you want. It's just kind of a review point for you that are writing this. Good? Because you already have that information.
There always be actors.
Not always. The second one there do not have any. So it could be 0, could be 1, or more.
The use case diagram. What do we?
Again, it's just a revision point to be sure that you are reading your diagram while writing this. Because the idea is the following. The diagram is something that you do with your team in a brainstorming session. But then you split these templates between the team, and maybe he's doing one template, she's doing one template, he's doing another template, because not the same person is going to do this, again, assuming a big project. So the big picture, the diagram, is a collaborative effort, but then the text is one person, and it's just a checkpoint. That is the reason that they manage it. Extra information, the tool is going to do it automatically again, because it's in the diagram. But again, if not, just add it. Remember the trigger. Remember that you want to put that this is going to happen when the user click here, or click there, or press this key, or whatever. Trigger, that is the place in which you tell me how this functionality is going to be called. That is your moment to explain the user is going to select from a menu. The user is going to click this hyperlink. The user is going to press the letter N, Y, C, the arrow. That is your point. In that moment, you specify the trigger, how this functionality is going to be called by the user. Clear? This is the only place, the only one to establish the trigger. There is no other place, no diagrams or other places in which you specify your triggers. Now, this one, as the previous ones, is optional. Why is optional? Because if you think about the Pac-Man moving, your trigger is the user press the arrow keys. Pac-Man moving have a trigger. But if you think about the ghost moving, that do not have a trigger. They are moving from the beginning of the game. And again, you do not need to put as a trigger the user run the game. We assume that the game is running. There is a trigger. There is something that one of the actors do in order to start that functionality. For the ghost moving, as you can remember, they are moving in one particular way inside of the house from the beginning. There is no trigger. It's just happen always with the game. Good? Similar with the aliens in the other game. For the enemy, no triggers. For the spaceship that you control, there is a trigger. The trigger, the arrows that you move, only left and right. Good? Okay, done with the easy ones. The second part, the complicated one, is you need to tell me exactly how this requirement is going to work. Now is your opportunity to explain to me the ghost move, how? The Pac-Man move, how? Give me the details. And the details basically mean explain to me the flow. Think about this like creating a pseudocode or flowchart diagram for something that later is going to become the source code of that particular algorithm. Explain to me the algorithm that is behind of this requirement, whatever is the name that you put there. Now, as you can notice, you have here two options. Option number one, you can explain the algorithm in plain English. You can use numbers. You can use bullets. You can use equations. You can use pseudocode. You can use whatever version of plain English or pseudo plain English that you want. Imagine that one of your requirements is to implement Dijkstra algorithm or some kind of sorting or searching. Probably it's something that you already have in English, or it's something that you already have somehow described with maths, with a loop and some equations happening. You can do it like that. Basically, in the table is going to say description, and the only thing that you need to tell me is the order, usually with numbers or with bullets, and I assume that is sequential, and explain each of the steps. I put here a small table, but obviously can continue. And again, there is no particular requirement for the English. I am going to show you some examples for that one. If you go to the book, examples for that part are going to look like this. You can notice the full example by something with some preconditions, with some actors, with some trigger things, la la la. But you can notice this part. Steps 1, 2, 3, 4. Okay, 3A, 3B, 3A, extensions, variations. People here describe this is the basic things that are going to happen. But for the 3, that is this 3, there are some possibilities. For the 4, some possibilities. For the 7, you know what? The 1 specifically could be different with this, or the 7 could be different with this. I am not telling you that you should do this separation, but this is one example in which the people think that this is a good way to explain the process. All these activities, all the activities for this requirement. Remember, this is one requirement, one thing that we already decided that was complex, right?
How do you differentiate between a description?
It is not part of the template. Here is the titles that someone, him, decided to use. He decided to describe the main process and then describe these variation extensions that we can understand, like, okay, variations, okay, extensions, particular cases, extensions, variations, things that could change a little bit. This is one way in which one person explained this. But again, this here is the communication skills that this particular person has. This is one example, one way to do the things. The only mandatory things is, as you can show, the numbers. Somehow you need to specify what is going to go first and last, and try to explain the step, trying to explain the instruction. I mentioned before, pseudocode. I mentioned before, bullets, numbers. This particular example is, okay, I am going to use numbers, but also I am going to use these letters. And someone could be thinking like, can I put this 3A here before the 3? Or can I put this like 3 and then A, B, C, D? Yes, you can. Is try to explain in the best way possible the algorithm. I am not going to stop to describe this algorithm, but my recommendation, my request for you, read the use case. The title is something about buying things. Read the description. It really is a full description of buying things. Hopefully, yes, it's an example for the text. Now, this is just one way to do the template. Another one. Another example also for the textbook. You notice the number. This is the use case 15. And they put zeros before, looks fancy. The title, register a book law. Okay, the description, the precondition. And you notice the precondition is not just the name of another requirement, but something longer. Plain English, up to you to describe the preconditions. You can notice that the people do not exactly follow this at the top and this at the end. My recommendation is this at the end. That is the template that you're going to have in the tool that you are using, ASTA. However, there is no mandatory thing. Is preconditions are here, postcondition, exception, comment. There is even a comment field. You can add things as you need. However, the important things, description, precondition, the actors are not here, but this is the most important one. And you can notice for the details, the steps are used numbers. And for each number, an action to happen. The details, the activities, the conditions, the states for this particular requirement. This one is the one that looks more clean, 1 to 9, and things that are going to happen. But there are others more crazy. There are people that decide, wait, if I am going to explain this process, I want to talk first about the inputs and the source of some data. This is something related with a sensor. So I am going to describe first what is going to be the input. Okay, what is going to be the source for that thing? If you notice, this is kind of the step 0 in which you explain your attribute, your global variables, or the hardware that you're going to have connected. Whatever help you to then specify what is going to happen. And as you can notice here, this is not for a developers. The action, the steps, is use this paragraph. This in particular from the textbook, one textbook, do not either put bullets or numbers. Just put this paragraph that you can read. And if you read the paragraph, it's kind of, okay, something is happening and then something is going to happen and then something is going to happen. There is this idea of a sequence, but not even with numbers. Obviously, that is the one that I do not recommend you to follow. I think you can value the importance of the numbers or at least the bullets. But again, there is no a particular rule. It's just about separate preconditions, postconditions, and probably the most important, the details of what this requirement is going to do exactly. Make sense? Now, these are just description with text in several different ways. Now, can you agree with me that using text to describe something is not exactly the best way to do it? Not for us. It is valid. You can do it. However, at this level, you can agree with me that the best way to describe something is with a picture, with a diagram. Okay. The diagrams. You have this oval. Remember, one oval. For the oval, you are going to give me this use case template with the information that I show you. Now, in particular, for this orange part of the use case template, for that part in which you are going to explain the details, you can use text, as I showed you the example, but even better, in that point, you can put a diagram. Which diagram? An activity diagram or an state machine diagram. I need you to remember, you are in a use case diagram with a lot of ovals. For each of the ovals, one of these tables, and for each of these tables, the information that you need to describe can be text or can be diagrams. Make sense? Professor, it is mandatory to use diagrams. The answer is no. There are going to be things that you can explain better with equations. There are things that you can explain better with pseudocode. Or there are things that you just need to explain in plain English because it's too early to explain what is going to be the process thinking about programming. It is a good idea to explain things with a diagram. Yes. Why? Because doing a diagram, you can recognize the complexity of what you are going to need to do later. Diagram could be the best idea. Moreover, we are human beings. We understand better the things with pictures than having to read a long set of text. Make sense? Okay, diagrams. Guys, as you notice, there are two things that you want to explain regarding the details of a requirement. Number one, you want to explain the actions, the steps, or you want to explain the data that is involved. You want to present information, extra information for the actions or for the data. Clear? If you need extra information for the actions, what you need is an activity diagram. Again, activity diagram is all about actions, instructions, things that are going to be done. If you want to provide information about data, values for variables, objects that should exist and do not be null, whatever, what we are going to use for the data is state machine diagrams. One state, what we call states, is values of attributes. Not only one value, but a collection of values in a particular moment of the time. Those are the states. Data, states, activities, actions. Clear? Now, that means that I could have, for one requirement, inside this template and one activity diagram and one state diagram, one and one? Yes, if you need to explain data and activities. Can I have only the activity diagram? Yes, if you do not need to explain data, you do not need to put a state diagram. Use the activity. Can I have only the state diagram? Yes, you only need to explain data, not activities, not the steps. Could be the case that the activities are too easy, or the activities are better explained with an equation, and the data is the one that you need to represent better with a diagram. Can I have none of them? Use an explanation with a paragraph in text, no diagrams connected? Yes, it's up to you. What do you need to explain? Both, one of them, none of them. Up to you. Clear? Good. Just remember, and this is the most important thing for your exam. If you want to represent actions, it's an activity diagram. If you want to represent data, it's an state diagram. Common error. I am going to ask you a question, and in the question, every information there is going to be about actions, activities, instructions, conditions. And if you use a state machine diagram to represent that,
So actions are
actions or conditions, activities, data, states. That is the main separation here. Common error, mix them. Good?
I put some, write it down. I put actions and then arrow activity diagram.
Activity diagram, actions. Actions mean instructions, conditions, steps. It's going to be in the slides, don't worry. Good? Okay, now, that is the reason because I need to introduce the activity diagram and the state machine diagram. Now, if you remember, they are part of the family of UML diagrams. In fact, they are brothers of the use case diagram that we reviewed before. You know this guy. We are going to review. We need to learn these two guys. And again, they are brothers. But remember, this guy, this first brother, have the other two inside. They are brothers here, but these two guys, the activity and the state, they really live inside of each of the ovals of the use case diagram. And that is hard to connect. They are not equally important when you think about a system, right? Clear? Good. Now, the first one, probably the most complex one. I am going to move forward with the activity diagram. Now, something that you are going to notice in the tool that hopefully help to connect with what I described before. If you have used the tool, you have noticed that when you create a use case diagram, you have here these ovals that correspond to each of the ovals that you create, right? So if you want to edit one of the ovals, you click there, you do things. You are going to notice, hopefully you did already, that if you click right to one of the ovals, options that you have is create a new activity diagram or create a new state diagram. Moreover, you are going to notice that these guys, the activity diagram is inside of the oval. And the state diagram also is going to be inside of the oval. Just like I told you, they are inside because they are explaining the details of the ovals. So your project, your requirements so far are going to be a bunch of ovals, right-click, template, and you can create the template here, or right-click, activity, or state diagram, and they complete your index, and then the details. If you haven't done this, if you haven't noticed this, please check. You are going to be working with this for the next homework. Clear? Good. So activities. Activity diagrams. And this is the information that you asked me before, so it's here, kind of. You can review it later. For the activity diagram. Things that you are going to put in an activity diagram. Remember that we're talking about the actions and the conditions and the steps. One activity diagram is going to show the flow of activities. Finally, we're talking about the order in which things are going to happen. Flow. The flow is going to include activities, steps, conditions. Those are going to be our new elements to connect. And this flow is going to be either sequential activities, something that happened first, and then another thing, and then another thing, or even things that should happen in parallel or concurrently. The activities, the conditions, the steps, and the order in which they happen. That is going to be the activity diagram. And you can connect this with the idea of the numbers, with the activities or the bullets, order of things that are going to happen. Clear? Probably the most important thing to remember here is steps and conditions. We're going to have conditions. And the other is sequential or concurrent, or sequential or parallel. Tell me, just to be sure, before I answer the question there, is do we understand the difference between parallel activities and concurrent activities? Do we understand the difference between something happening in parallel and something happening concurrently? Ideas?
Parallel maybe like running together, and concurrent can like both are running together, but one may not.
Parallel means both are running together and they're not dependent.
Okay, you have the idea. Let me tell you this. Your computer can run two things together. Yes or no? What do you need in your computer to run two things concurrently?
Bench.
At least two CPUs. You can run two things in parallel. Parallel execution, parallel programming, parallel activities imply that you have the hardware for two things to happen at the same time. Right? Question. As a professor, can I be speaking with you and also checking if you are doing copy paste in your exams?
Yes.
In parallel? No. Why not? I have only one brain. Never in parallel. I am speaking and checking if you are doing some plagiarism thing or what you are doing. That happened concurrently. Concurrently, yes. If you have only one CPU, concurrency means simulate parallelism. Concurrency or concurrently mean you are going to make the things looks like parallel, but it is not parallel. In terms of your computer mean what you mentioned before, I am going to run two processes, Word and PowerPoint, or speaking and checking. But really what I am going to do is 5 seconds one, 5 seconds the other, 5 seconds the other. use blocks, and for the user look like they are at the same time, parallel, but they are not. Parallel, real, two things at the same time. Concurrency, concurrent, two things that happen kind of at the same time, but it is not at the same time. Make sense? Now, really, at this level, that is going to become important when you do the programming, because in the programming, you need to review if you are going to have more than one CPU. Right now, for the requirements, talking about parallel execution or concurrent activities, they are for us at this level the same. Things that are going to really happen at the same time or somehow simulated that are going to be at the same time, but right now we do not care. Make sense? Good. So, examples. You are going to notice the following elements, and I need to be sure that you can identify them and know what they are. One, we're going to have rectangles, and you're going to notice that the rectangles have rounded edges. Don't worry, you're going to be using a tool, so you're going to have these rounded rectangles. A rectangle represents one instruction, one activity, one step. That is your rectangle. One instruction in your program, one activity to do in the process, one thing to happen. Every one element to happen, every individual thing is going to be one rectangle. Now, you are going to have diamonds. Conditions. Diamonds, a condition, one input, two outputs, true or false. True or false what? The condition inside of the diamond. You're going to notice in the tool that you're using, the diamond is going to be small, the condition is in some part close to the diamond. Clear? You're going to have diamonds with one input, two outputs, or diamonds with two inputs, one output. The beginning, the end. Start and if else, closing the if else. Or starting the switch, closing the switch, begin and end. Clear? Professor, what if I need to create more than two paths? Diamond in two, you want more than one path? Another diamond in two, and now you have three. If else inside of an if else. Clear? Bars. You are going to have bars. Really bars. A rectangle here, a rectangle here, one bar here. Can you get what this means? Bars to open the parallel part, bars to close the parallel part. You can think about this like start a thread, join the threads. Bars. You are going to have circles, a black circle and another one black circle with another circle outside. So you're going to have this guy and you're going to have the same guy, but with another circle there. Beginning and end. Let me be clear. When you create a diagram, an activity diagram, the only way that you can start is in the starting point. When you move into the diagram and you follow whatever path you want, there is always should be one way in which you reach the end point. That is your challenge. You're going to create an activity diagram. You always start here. And there should be a path for every activity to reach this point. I am talking about something like this: diamonds, rectangles, circles. This diagram is correct. How do you know that is wrong?
False is not ending.
Clear. Guys, very common error in your exam. And the question is going to be, 10/20. Can I have partial credit? The 10 are your partial credit.
What exactly is wrong with that?
Help me, what is wrong with that? Someone else, help me.
Every case in a decision has to be, right?
Yes, every path that you start here, if you follow any arrows, like I am going to follow this, and here I am going to follow there should be one way to reach the end. And here is like, okay, what I do now? You end here, but now you cannot move. There is no path to follow to reach the end. And that is a big mistake. Make sense? So this one, for instance, somehow need to connect with the other. Yeah. Very good question. Guys, my recommendation, usually the thing that everyone is going to tell you, and in particular, for instance, here in this example, the recommendation should be like, you know what? Let's do another of this. Let's connect this here. Let's connect this here, and this go out, and this one go to the endpoint. This could be the recommended solution. Why? Because this one shows that this is an if, that the if ends here, and this is the beginning, this is the end. It's kind of very clear to notice, right? However, think about a diagram that do not fit in one page. Think about one diagram that you are going to do, and maybe the diagram itself, because of the complexity, is several pages. And if you think about several pages, just think about this is going to be split here, and from one page to the other, you're going to run 2 lines. If for a good reason, having this make the reading more complex, like when printing or whatever, it is valid to do something like, well, you know what? Two ends. But again, the only way in which this is going to be okay is if there is a good reason in terms of the size of the diagram, in terms of how you are organizing the diagram in the printing or in the pages. So you can make a case for this to be okay, because, okay, after this one end, the only way for that is to connect the things, close the square brackets, and both are going to go to the end of the method. I do not recommend you to do this. What you are going to do in the exam is not so big. So if you put something like this in the exam, I'm going to make the note like one endpoint is better. It is not totally wrong, but again, only if you can justify doing it.
Have just one endpoint and both the lines just connected to it without the condition?
Yeah, you can also have, and this is another thing that you're going to notice in some books. You need to remember that there is several versions of UML. So you are going to notice that if you go online and review examples of UML 1 point whatever, anything that is starting with 1, it's going to be a little bit different than the things that you review as a UML 2. Something that was valid before and no one complained was something like, you notice that there is not another diamond. You notice that the only diamond is the one with the condition. The second diamond is not mandatory, but this looks more like old times than the things that you have right now. For instance, if I am correct, the tool that you are using is going to ask you to put another diamond in order to close the lines. It is not going to allow you to just like connect these lines there, 3 lines together, hopefully. Make sense? So this is not wrong. It's just an old version of UML. The recommendation now is please put 2 diamonds, open and close. Make sense? Clear? Okay, now, as you notice, we're going to be using solid lines only. Guys, if you put lines with a dash in an activity diagram, I know that you are mixing use cases with activities. Activities only solid lines. Moreover, activities, always, always, always you have an arrowhead. And never, never, never the arrowhead looks like inheritance. Do not put here be careful. Arrows. And the swim lines, I am going to show you the example. But with these elements, if you have this use case, customer checkout payment service, it's an easy one. And you are going to explain to me the details of checkout. What we're going to do is, okay, go inside of checkout. And when you go inside of checkout, you are going to have maybe something like this guy. Again, you need to remember that this guy is inside of one oval. This diagram is giving you the details of one particular oval. It's never about the full system. For that particular oval, starting point, end point. For this particular thing, activities in parallel, closing the condition, another activity, ending. This is a diagram that looks like or is created with the tool that you are using. So these are going to be the kind of diagrams that you're going to have. Make sense? Common error, guys. Tell me, starting point. A bar. That diagram, good or bad? It is bad. Do I need to explain why? I am assuming that you can notice that, like, wait, if you are starting 3 processes with 1 bar, can we agree that this kind of mandatory? I am assuming you have this experience with threads before, but the idea is that the same bar at the start 3 should be the bar closing 3. This is not a representation of something that you are going to immediately do programming. However, what I am assuming is that you have knowledge of programming, and therefore you know that this or something like this cannot be possible. Something like this do not make any sense. If these 3 are threads, this should close here. Moreover, this one cannot continue to start another version of these 3. I am assuming that you have a previous knowledge about parallel concurrent activity. I am assuming that you have previous knowledge with conditions. And I am giving you some examples for you to review. But I need you to review and notice that something like this as a solution of a problem is wrong. Not only because do not match the description that I am going to give you, but because whatever reason you have to draw something like this is telling me that it is not clear for you what is happening in the activities. Something like this is wrong, and we are going to have a low grade in your exam.
That diagram, we had a retry option, and it would have come back.
Yeah, in this one, instead of the condition here, you can think about a loop. The loop have only 1 diamond, and basically this arrow could go in this direction and just repeat things. But that is going to represent a loop. And inside of the loop, you have this instruction of starting the threads, joining the threads, and again, and again, and again. That is valid. Just, I need you to double think when you are doing the diagram, if that work in programming, if that work with the knowledge that you have about parallel execution and other things.
Diagram. Wrong.
In the diagram here, the first thing that you need to notice, I mean, the first thing to fix is these three starts together. The three of them should close together. Now, this is a condition. What do you want to do? You want to put maybe this condition after the parallel execution finish or before the parallel execution finish. Maybe what you want to do is this one, you want this inside. Or maybe what you want to do is, okay, this one do not go there, but maybe this one is something that you want to execute this one several times. This is different from the previous one.
Say those are thread 1, 2, and 3. Let's say 2 and 3 have joined already, but 1 is joined later.
That is possible. Like the other idea that you have is, you know what? These three are going to start together, but these two need to join first, because after these two join, something here is going to happen. But then this is going to wait for this to finish. So something like this is also valid. Very good point. I am not expecting the three of them close in the same point, but you can use like the if else in a condition. Makes sense. So probably the most complex part in your exam talking about activity diagrams is going to be the part in which I ask you for something to happen in parallel. And the one that I showed you here was kind of common errors that people made. So just be sure to review and understand the parallel execution threads, how they start and how they stop. Good? Okay, another one, maybe more complex, this one. Do we understand this? Starting point, end point, and something happened. Correct, incorrect, not resolved, resolved. You're going to notice the conditions inside of your square brackets. Common practice is going to happen, in particular in the tool that you're using. Condition, not amount available, amount available. You can put the condition there. Opening, closing. I put this red circle here to help you to notice opening and closing. 2 input, 1 output, 1 input, 2 output. That is the only reason. As you notice, there is nothing mandatory to the left, to the right, up or down. It's just make a diagram using the best way possible your space and be sure that the diagram is easy to read. And hopefully the examples that I show you are easy to read. As a homework, check the previous one, check this one. This one, before we go, did you notice that in this diagram I have 1, 2, 3 columns? If you have a requirement without actors connected, you are going to have a diagram like the one that I showed you before. If you have an oval with 1 actor connected, you are going to have a diagram like the one that I showed you before. When you have an oval with more than 2 actors connected, something that you need to specify is, okay, there are 2 actors here. Who is doing what? Again, no actors, use the description. 1 actor, use the description. But when you start with 2 or more, you need to specify who is going to do what. Which of those 2 is doing which part? Which of those 2 is going to validate the condition or whatever? What we do for those scenarios is swim lines, columns. 1 column per actor. So if I have 2 actors connected with the oval, remember, this is 1 oval, 2 swim lines. In this particular case that I am showing you here, what I have there is an oval with 3 actors connected. At the top, you can read later the 3 names that correspond to the names of the 3 actors. And this is being done by 1 actor. All these conditions, parallel execution, and so on, by 1 actor. And these condition loops, whatever, by another actor. Make sense? Last comment, please. If you use parallel execution, a rule, and hopefully it's clear, if the parallel execution starts in one actor, it should close in the same actor. Think about it. Two different actors, this cannot start and this close. Do not make sense. This start, this close. Good? Review this. We are going to continue after spring break. Therefore, your exam is moving to Monday. See you.